without further ado, let's start with something very, very simple. So I write this, a very simple C++ statement, and we're going to examine this and see what information we can withdraw from this and see if we can identify something that maybe is not so obvious unless you are an expert in type systems. So what we have here is that this is a C++ statement that says that the variable x, so this is the name of a variable x, this variable is of type int, which stands for integer, and we're defining it to have the value 4. So we're using one of the ways in C++ to instantiate and define variables. So we'll use this curly bracket instantiation. I think it's called the uniform instantiation or creation semantics. So yeah, let's begin there. So this is a type. This is a variable, and this is the value. So that's simple enough. But let's go further and see what we can do with this. So let's say I start to take this apart and say, okay, let's write it like this. So we move the type up to its own level, and then we put x down here, and then we put the value here. So why do I do this? Well, now we can say that this is, well, I can call this value for now. Now this is now x is of type int, and it has value 4. The interesting with writing it like this, and what I'm going to aim at, is that maybe now we can say, okay, this is a name. So I put this, what is called in English? Well, in C++ I state this is a text now. So it's a way of saying, okay, x is actually a text, and the text is x, and this is a name. And let's do the same thing with the type here, because int is also type, also text, and the text is the name of something. So in the same way that x is a name of a variable, we now have said that int is a name of something. So what do we have here if we follow this line of thinking? Well, that's valuable to think like this, and that's what we're going to examine now. So let me redraw this. So we have type, int, and we have, well, I do it like this, var variable x, and the question now is, what is int? What can we say that int is like is for thing? Well, if you read type theory, or if you have been thinking about this or heard it some elsewhere, we can say that the type int is actually a set, because what int means is that if x is of type int, then x can only hold the values that int defines that it can hold. So we can say that int is actually something, it's a list of, or a set of, well, we have -1, we have 0, we have 1, we have 2, we have 4, and so on. So it's restricted. So the int type is actually a set of all these integers, and we are actually defining x to be 4. So when we go back here, this statement here states that the 4 in here is actually a selection from the int set. So we pick the value 4. So let's continue that line of thought and say that we have the type int, and instead of saying this is a set, let's say this is an object that, well, how should I draw this? Well, it's some, well, let's call it an int object then. Maybe that's semantically not the best way of doing this, but I do this anyway. So we have x. So we go back to this here. How can we interpret the curly braces 4 here to mean in this expression? Well, as I said, we can look at it as if we pass the value 4 so that the variable x is defined to have the value 4. So maybe if we look at this object here, that what we actually are doing is we pass the value 4 to something here, and what happens is that this object here actually creates this. Okay, so what we've done now is that we are defining or looking at it semantically, that int is some kind of object here that can create variables of this type. And what this object has is a constructor that takes the value 4, and it also takes the name, and then it instantiates or defines variable x to have value 4. So the interesting thing is this object here. And this is what I'm aiming at, and I find this interesting, that whatever we call this, we can look at this as being, well, kind of a function. So if we go back and we look at the original instruction statement, this looks very much like what we in functional languages recognize as an operator with 2 arguments. And the result of this is a variable with a name and a value. Okay? So let's start over here. We can write this, if we go back to the C++ statements, and we write this as we would in a functional language like Haskell or Elm or, well, what have you. Then we would say that int is a function that takes a name and a value and returns a variable, well, with a name. Okay? So this starts to look interesting. Then in our reasoning now, we have concluded that we can look at int as a function that takes a name, takes a value, and it creates a variable with that name and value. And this is the core idea of something I'm hereby is going to call the tar model, just to be able to talk about this. So in the tar model, for now, I'm going to state that we have this relationship between variables and type. So this is the model where int is an operator, and in this case x is a variable, and this operator is specifically a constructor of named ints. Okay? I'm going to stop here for now. This is just an experimental video, the first one, where I'm trying to find a way of explaining this tar model thing here and see how it works out. So maybe I find a better way of talking about this. And well, that's all for now. Thank you for watching, and just keep in mind that I will continue to talk about tar models of C++ and the C++ type system in this way. So the takeaway here is that we recognize that we have two levels. We have variables here and we have types here, and the relation between them is that the type actually is the constructor of, well, really stuff on the variable level here. Okay, thank you for watching, and see you next time.
If you like my videos, feel free to do nothing.
Just grab a cup of coffee
and enjoy.